Okay, hey, good morning everyone. Very excited to speak to you today. I already heard a lot in the first two talks that resonated with the things I want to talk about today, so that's cool. My name is Hein Hoogstad. In my previous life, I was a professor in philosophy and cultural studies, but that's all behind me. Nowadays, I'm running a startup called Of Course. Of Course is going to radically change the way you learn new skills online, but that's not what I'm going to talk about today at all. Please check out our website if you want to know more. Today, I want to talk about buildings, actual buildings, houses, homes, towers, bridges, etc. I will focus on what these constructions share with the artifacts that we developers build ourselves, programs, libraries, and applications. The element that connects these things is called architecture. The inspiration for this presentation comes from a comment that a good friend of mine once made when I told him that I decided to use ClojureScript, again ClojureScript, I'm sorry, as the language for the, of course, front-end application. While I cannot remember his exact words, it was something along the lines of, all that functional stuff, immutability, no side effects. I understand why this makes sense on the back end, but on the front end? What fascinates me about his remarks isn't the actual words, it's the assumptions that underlie these words. Let me spell them out for you. In my opinion, his comments suggest that the backend is complex while the frontend is not. The backend represents the core product, while the frontend is merely a byproduct, something that is used for marketing purposes or something. Consequently, the frontend is just a temporary artifact, while the backend should be a long-term investment. And last but not least, he implies that architectural patterns are very important on the back end, while the front-end developer should just use whatever works for him or her. In my experience, his opinion is not unique, but quite representative of the developer community at large. My own view on front-end development, on the other hand, are diametrically opposed to these assumptions. I believe that architecture does matter tremendously on the front end, today more than ever. Before I go into detail, I want to briefly mention two points that support my opinion. First, the current rise of the unfortunately named or misnamed serverless architectures mean that the front-end client application is becoming more and more important. Obi Fernandez, for instance, claims that serverless application architectures offer tremendous cost savings and colossal horizontal scaling ability, with the side benefit of encouraging loosely coupled design. The advantages are so profound that the days of monolithic application servers might be numbered. Without a traditional backend, however, the client, rather than the server, is the place where all the different services come together. As a consequence, seriously thinking about front-end architecture is no longer a luxury. It has become an absolute must. Personally, however, my primary reason for valuing proper design is a different one. I believe that not thinking about architecture is a mistake in under any circumstances. Here, I'm in the company of a statesman like Winston Churchill, who claimed that we shape our buildings, thereafter they shape us. Not thinking about the architecture of our programs means that we're shaped by implicit rather than explicit design choices. The rest of this presentation will consist of three parts. In the first, I will talk about architecture in general, how its use in software development is significantly different from its physical counterpart, and why this matters to us as developers. In the second part, I will explain a few software design patterns and show what they look like if they were actual buildings. And the last part focuses on common front-end architecture patterns and anti-patterns, and how we implemented a serverless architecture in ClojureScript at Of Course. And I'm afraid that there's a little bit of duplication with the previous presentation in that last part. So, first part, architecture. Alan Kay famously said that Lisp isn't a language, it's a building material. To me, this is exemplary of the way developers conceive architecture. We understand it in terms of building blocks that we use, such as languages or abstractions, libraries, frameworks, patterns. Even though code reading groups are becoming more common, like the classical code reading group, for instance, the actual artifacts that we produce are still rarely discussed. We don't talk about programs like we chat about books or our favorite Netflix shows. We cannot stop comparing languages, patterns, and libraries, but often forget to look at the actual product of these building blocks, the program as program. Real-world architects, on the other hand, tend to do the exact opposite. Daniel Liebeskind claims that architecture is not based on concrete and steel and the elements of the soil. It's based on wonder. Although his quote is a little bit too new agey for my taste, it does clearly illustrate the way architects view their profession. To them, architecture doesn't deal with the building blocks that they use. They care about the construction that emerge from these individual pieces. Leave it to the philosophers to go even a step further. Roland Barthes, for instance, said that Eiffel saw his tower in the form of a serious object, rational, useful. Men return it to him in the form of a great Baroque dream, which quite naturally touches on the borders of the irrational. Architecture is always dream and function, expression of a utopia and instruments of a convenience. To put the same point more simply, architecture is always an expression of a future that can be or could have been. It's the materialization of common ideals. Architecture is what Aristotle called an ethos, which literally means accustomed or lived space. Aristotle's great successors, Burt Beckerett and Holt David, translated this ancient world into an easy-to-understand fact, namely that a house is not a home. To sum this section up, architecture is actually always three things at once. It's a material representation of a desired future, an expression of a set of ideals, a lived space, an ethos, a home. But it's also a technical construction, a feat of engineering, the product of many tough choices, a house. Finally, architecture is always a set of building blocks. Or, as the famous architect, modernist architect Mies van der Rohe said, architecture starts when you carefully put two bricks together. There it begins. Ooh, I'm behind, sorry for that. So software and architecture, I cannot see on my screen where I'm at, sorry for that. In this section of my presentation, I will look at different software architecture patterns by comparing them to actual buildings. The best known and probably still commonly used software architecture pattern is the so-called layered architecture. The main principle behind layered architectures is that of a separation of responsibility. Each layer is responsible for a finite amount of work, says Jean-Paul Baudou. I hope I pronounced his name correctly. This is comparable to the classical home layout as idealized in the dollhouse in the picture here. Each floor has a clearly defined responsibility. The bottom one consists of the living room. The middle is the parents' bedroom, and the top one is where the baby sleeps. In software development, a layered architecture can be stacked infinitely, but in its simplest form, it consists of a persistence layer with business and presentation layers built on top of it. Unfortunately, in practice, however, layered architectures often end up like this Escher painting. This is due to the fact that the theoretically clearly defined layers of such an architecture can easily get mixed up. And yes, I mean Ruby on Rails with this. To quote Jean-Paul Baudou, unfortunately, people using layered architectures can often run into a scenario where they introduce an unnecessary amount of coupling between the layers of their application. As a result of this tight coupling, layered architectures are often hard to scale, reuse, and refactor. The microkernel architecture, or also called plug-in pattern, aims to correct the flaws of the layered architecture. This architectural pattern applies to software systems that must be able to adapt to changing system requirements. The kernel in the name refers to a hub-like core that can be extended by plugins or adapters. While this may not be a common pattern in real-world architecture, it's one of the oldest. The Oude Kerk in Amsterdam, Old Church, for instance, was built using a very similar design pattern. This is best illustrated visually. First, look at the church's original state around 1306. So it looks like this at that time. And now look at its current form. The core church is still intact. I cannot really even find it, but you have to believe me, it's still there. But it's hardly recognizable. Over time, it has been augmented by many small modules that each extend the original building with custom functionality, such as housing, catering, and also, ironically, prostitution. The following quote about the microkernel pattern could equally apply to the architecture of the outer Kerk. Sorry, mixed the languages there. It separates a minimal functional core from extended functionality and customer-specific parts. The microkernel also serves as a socket for plugging in these extensions and coordinating their collaboration. But no presentation on software architecture in 2016 would be complete without an extensive discussion of everyone's current favorite, the microservices pattern. Martin Fowler defines it as such. The microservice architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, often an HTTP resource API. Just like most modern airports consist of separate terminals and other buildings that each serve a particular purpose, the microservices architecture loses the concept of a predefined whole. In direct contrast to the microkernel architecture, microservices do not need a central hub to work properly. Each service functions independently as well as in conjunction with others. Although microservices are not as uniformly defined as the others, they do have a couple of shared characteristics. The first is that the business logic of an application is distributed over multiple components. Each of these components has its own clearly defined domain or responsibility and gets deployed individually. This usually happens in the form of a Docker container, or ever more frequently, an AWS Lambda function. These individual components individual components communicate with each other through a message broker, 0MQ, RabbitMQ, or something similar. This marks the second characteristic of a microservices architecture, smart endpoints and dumb pipes. I will come back to this in a moment. Furthermore, microservices are designed to handle failure gracefully. The way to accomplish this is to avoid synchronous coupling between the components as much as possible. Instead, the components only communicate via the aforementioned messaging pipeline. This allows for replicas and backups in case one of the individual services fails. Lastly, microservices are characterized by an evolutionary design. They are commonly part of a continuous deployment pipeline. As a result, developers can roll out individual features one at a time, rather than fitting them in periodical release cycles. Before I move on to the front-end section of this presentation, I want to zoom in on the smart endpoints and dumb pipes. In my opinion, they constitute the heart of the microservices pattern. Martin Fowler describes this as follows. Applications built from microservices aim to be as decoupled and as cohesive as possible. They own their domain logic and act more as filters in the classical Unix sense, receiving a request, applying logic as appropriate, and producing a response. This flow of events should be easily recognizable to any functional programmer. In a microservices architecture, each component basically works as a function with clear inputs and outputs. A microservices architecture and functional programming are therefore a natural fit, in my opinion. Unfortunately, this airport terminal is an impure function, but we can talk about that later. To me, the appeal of a microservices architecture lies in the fact that it encourages a developer to think about her specific domain. As opposed to all other patterns that I've discussed so far, this one doesn't try to force the domain knowledge to fit the architecture. At the same time, the domain informs the design but doesn't enforce it. Or, as the architect Ove Arup, I hope I pronounced his name correctly, puts it, engineering is not a science. Science studies particular events to find general laws. Engineering design makes use of these laws to solve particular practical problems. In this, it's more closely related to art or craft. And this brings me to the final section of my presentation, and back to the quote of my friend. Because from a beautiful architecture, it's only a tiny step back to his objection. All that functional stuff, immutability, no side effects. I understand why this makes sense on the back end, but on the front end? By now, I've hopefully convinced you that it's important to think about architecture in general, but I haven't explained why and how this applies to the front end. My answer will be a very simple one. The microservices architecture is a good way to use for a serverless front-end application as well, even though the code will run on a single client rather than on distributed servers. I still consider it valuable to design the application as if it's a collection of services. Before I explain the what and how of the serverless front-end architecture that we use it, of course, I want to discuss some common alternatives. First, the so-called shantytown architecture, and second, front-end frameworks. Unfortunately, the lack of any deliberate architecture is still prominent on the front end. This anti-pattern has many names: shantytown, big ball of mud, but in front-end development, it's best known as jQuery spaghetti. Brian Foote and Joseph Yoder describe the dangers of such an approach quite vividly. Too many of our software systems are architecturally little more than shantytowns. Investments in tools and infrastructure is often inadequate, and the tools that are used are primitive. Parts of the system grow unchecked, and the lack of architecture and planning allows problems in one part of the system to erode and pollute adjacent portions. Deadlines loom like monsoons, and architectural elegance seems unattainable. So how do we clean up this shantytown, this big ball of mud, this jQuery spaghetti? Of course, my friend has the solution. Why don't you use a JavaScript framework instead? At first glance, front-end frameworks have a lot of advantages. Like the slogan for the Ember framework states, they make the coder more productive out of the box. Furthermore, frameworks also replace the law of the jungle that characterizes the shantytown architecture with conventions and best practices. In short, frameworks are the software equivalent of prefab houses. Unfortunately, frameworks also suffer from the same flaws as prefab houses. In the words of James Russell Lowell, compromise makes a good umbrella but a poor roof. This is from one of my favorite Tumblrs, by the way, ugly Belgian houses. It's great, it's really amazing, you have to check it out. Frameworks are a one-size-fits-all solution. They may help you to get started quickly, but often make it difficult to scale and customize your application later on. And from my own personal experience, I can state that I'm really looking at you, AngularJS here. While I have nothing against frameworks, like I said, some of my best friends use them, I would argue that they have little to do with architecture. Architecture is the art of designing tailor-made solutions to specific problems, to make spaces livable for the individual users. Frameworks tend to do the opposite. So of course, I decided to go a different route. Through trial and error, I designed a custom serverless front end. This design is based around exactly the same principles as a microservices architecture. ClojureScript, and I think we also heard that in the previous presentation, proved to be a fitting choice because it provided me with the right set of primitives, the right set of building blocks to implement the characteristics of this pattern, which is not the same as mimicking its backend implementation. So the way we implement it in the front end is quite differently than how you would do it on the back end, but the principles and the characteristics still maintain. In our application, we used Stuart Serra's creatively named component library to implement, you guessed it, the components. Common front-end services like a router, a data store, and a view renderer all function independently of each other. Core async channels are ClojureScript's alternative to a message broker, while the Go blocks of the same library help us to prevent synchronous coupling between the different components. Last but not least, the fact that ClojureScript's build artifacts are simple JavaScript files makes our deployment pipeline extremely simple. We just build, test, and sync static websites. So this all brings me to the conclusion of my talk. In this presentation, I've showed, hopefully, that architecture, whether physical or virtual, consists of three perspectives on the same thing. It is the blocks that the building consists of, the construction that hold these blocks together, and a set of ideals, practices, and expectations that this construction expresses. Again, a house is not a home. But even though I completely agree with Beckerek and David, I would like to add one tiny thing. Thanks for listening to me. Go out and build beautiful things. Thank you very much. Yep. Yep.
I have a question. What I've seen in microservices-oriented startups is that they run out of cash before they execute because they're doing this huge design up front.
Yeah.
And while I've certainly seen, the balls of mud that underlie Rails,
yeah.
what I tend to see is I can think of a lot of companies that deployed on Rails, built on Rails, and then had a pain point where they had to decouple and turn it down.
Yeah.
But they're successful. They live long enough.
Yeah.
Right? What I tend to see is people designing like your diagram of JFK Airport, is that they spend so much time in microservices that they never make it to market fast enough. So do you have any kind of concepts about the big design up front impetus behind microservices versus less elegant balls of mud?
Yeah, so a couple of things. I think first of all, and I think that's very important, it's a very good question by the way. The first and most important thing that I have to say is choose a language that supports this kind of architecture. So that really makes a difference. I think the previous presentation also made that very clear. These are in Clojure or ClojureScript, you don't have to reinvent, don't have to invent these things from scratch. The language already forces you or pushes you, and not forces you, but pushes you in that direction. That's one. Secondly, but that's more general startup advice. Try to bootstrap as long as possible. So if you do it in your own time and with your own money, you can spend time on this design. If you do it in someone else's time and there's a rush and a hurry. So I did a lot of the architecture before we actually really built a startup around it. Thirdly, you can make it as I think like the differences between, and I think here, and maybe most importantly, I think the difference between a microservices and a serverless architecture is becoming really crucial here. So I would say the real advantage of a serverless architecture is that you can start small. You can start from the client, but you have to think about the design. You can use services, you can use things that are already out there, and then gradually you can replace them, just like in the traditional Rails stack that you just described. So you can have the best of both worlds, I think. I think there's very, very important difference between microservice and serverless there. I think the microservices basically force you to have like a very, very difficult deployment pipeline in the end and a lot of things, whereas serverless actually allows you to do the opposite and really start from the front end and then introduce abstractions later on. Does that answer your question?
Yeah, that's very helpful.
Okay, then I think we ran out of time. So, okay, thank you very much.